Okay, so we're still looking at we're still looking at an arithmetic sequence. So arithmetic was when either you add or subtract the same amount. And so that's another way of explaining that is linear, the word linear. So if you graph what's happening with the terms, it would go in a straight line. But today what we're going to look at is when it's depreciating or it's decaying. So that means the value is getting smaller. So we saw with simple interest, the value kept getting larger because we're adding. Today we're going to look at things when it decays or you'll hear the word depreciates, means that the value gets smaller. So the first one we're going to look at, so we're sort of modelling, so we're doing financial applications. And the first one we're going to look at is called flat rate depreciation. So that's when a constant amount is subtracted. And so you can see here that's that D value. You can see that it's being minused there. So that's the decay. And the same as with simple interest, that the amount that we're subtracting is a percentage of the original amount. So you can see here, here's the formula where we are calculating what the D value was. And so remember they've put the R, which is generally the per annum percentage rate. And remember VO, they're using VO, which is the initial amount, okay? So it's always going to be, they're always going to subtract the same amount and it was percentage of the original thing. So as I said then, when you graph it, so you start off with the value of whatever you were talking about and then it goes down in a straight line. So just write that's a straight line to remember that. Okay, so here's a couple of other formulas that we might need. We'll just put them in the summary page. We won't worry about them at the moment. We'll go on to our examples. All right. So a new car is purchased for $24,000. So we've got VO there. That's our original in 2004. Now it depreciates by 20% off its purchase price each year. So I think that should be off its purchase price. So when it says off its purchase price each year, you might want to write, that's another way of saying flat rate. So you know how the other day I said, when you're reading your questions, you need to know, which formula in your summary sheet you're going to. So off the purchase price each year, so off purchase price, that's a way of saying flat rate. And here they're saying they're modelling this, they want you to model this scenario with a recurrence relation. So remember, they've got the summary here for us, but recurrence relation is where you state the initial one and then you also state the rule of how you get the next term. And they've been kind and put all the formula there and also how that we would find D. I'm just going to quickly show you on your summary sheet the thing, so I'll pause it for a second. All right, so I've gone to our summary sheet and you can see we've worked out its flat rate and you can see we have to write the recurrence relation. So remember the recurrence relation is this column here, okay? And they've pretty much written what they've written here because as I said before, they were nice giving it all. All right, but if we didn't have that, that's how we would find it. All right, let's go. So let's do this, write this scenario as a recurrence relation. So we first need to find the D value. Let's work that out first. So D equals the rate over 100 times VO. So in this example, it's going to be 20 over 100 times 24,000 because that's what our initial thing is. So we can work, so that's 4,800. So now I can write out my recurrence relation. So my recurrence relation, I have to state the VO. So you have to write that out, which is 24,000. And then you have to write the rule. Now the rule is, if you look at my notes here, if it's in black, you don't have to change it. If it's highlighted, you just got to make sure you're doing the right thing. So minus, and the D we've worked out. So there you go. So there we go. There we have our recurrence relation for this scenario. Okay, so let's do this next example. So we're okay here because they said the flat rate depreciation. So we know we're using flat rate. They've told us, and they've given us the model, which is, it's the same as the one before, but let's just see how they can ask us. So they said where VN is the value of the cars after N years. Use the model to determine the car after 2 years. So remember when I said when they ask you to use the model, you must show the working out like step by step. I know it's annoying, but that's what we've got to do. So we've got VO. So if we go after 2 years, we're going to show V1, and we'll go V1 equals VO minus 4,800, which is going to be 19,200, and then you're going to get V2, and you're going to say that's 19,200 minus 4,800, and you get your answer 14,400. So they've used the model to determine, so you might make a little statement, just say therefore at 2 years it is 14,400. Okay, and then B, if the car was purchased in 2014, in what year will the car's value depreciate to 0? Okay, so you can just keep clicking on your calculator. So if you'd set up on your calculator that recurrence way, if you like, so you know where we typed in, we would have had 24,000, and then you would have had answer minus 4,800, and you would have seen these ones clicking over. You could keep going like that. So if we kept going through that, we find out how many years it gets to 0 after 5. So, sorry, that was 14,400. Then you had 9,600. Then you were down to 480, and then you got to 0. So this was after 1, 2, 3, 4, 5. So you can there answer, therefore, after 5 years. The car, was it a car? Yeah, the car equals $0. Yep, good point. Someone just said, because it said what year, we should look at that. So it's 5 years after 2014, so therefore it will be in what year? 2019. Good call. Okay, so we've got an example of an exam question here. So Jeff purchased a computer for 4,500. So I always like to just go VO on the top as I'm reading it. He will depreciate the value of his computer by flat rate. So this becomes very important so that I know which formula I'm looking at. And then it says by 10% off its purchase price. So we can see that's how. There's another way to explain flat rate. So here we've got the rate there and the recurrence relation to use this thing. So you could pop in that, go to your formula sheet, and we're going to see we've got a recurrence relation. We need to write, first we write the VO, which you can see they all have that, so that's not going to be a point of difference. And then we would use our D value. Now, we've got to work that out. So here it'd be 10 over 100 times 4,500. So that's going to be 450. And this is flat rate. So remember, when we write our recurrence relation, it's VN, and then you write minus your D value because we're depreciating. It's going smaller. So which one is the answer for this one? A. Good. So as I said before, we're going to be now asked, like it could be annoying to just keep pressing enter in the calculator and just trying to get to a term through using the one before. So we changed to this rule where the nth term. So that's where you can find any like term number and you use this formula. So here's for flat rate. This is the formula that we can use. And obviously down here, they've just changed that formula and they've simply where they've put the D, they've put the D's formula there. So that's just it's written out in sort of expanded form. So it doesn't really matter. You know how to work out D, and there you go. So if we were, so this would give us a formula that allows us to find the value of whatever we're talking about at any time. So let's move to the example. So we've got an example here. It says, the following recurrence relation can be used to model flat rate. So here, we're definitely highlighting this, flat rate depreciation. So we know we're going to this part in our notes, yeah? We're going to the flat rate part. Okay, and they've done that. They've done this that's the recurrence formula there. That's the recurrence relation. Okay, so you can see that does look like this here, which is what recurrence relation. So first of all, we've just got a few questions about it. So let's go first. A, what is the initial value of the furniture? So looking at that recurrence relation, we can tell what the initial value was. What was it? Yeah, it was 12,000. So that's pretty easy. So the 12,000. And by how much does it depreciate? Does it decrease each year? Yeah, good. And it decreases by 1,200. Good. So that's just letting the examiner know that you can read a recurrence relation. Now, it says write down the rule for the value after n terms. So that means we're using this one. We need the nth term formula. So let's go and look at that. So when you write the nth term formula, you have to write, it's Vn minus, now we need to change, we don't write VO. What is VO in this example? Yeah, good. So we write Vn equals 12,000 minus, now we're going to say n times d, but we know what d is, and what is d? Looking up here, what's the d value? 12,000, good. So you go 12,000 times n. So that's the nth term rule. Or the, after the rule after n years. Okay, that's it. All right, and then it says in C, use this rule to find the value after 6 years. So that really means you're finding V6. So you write out your nth rule formula, and every time you see n, you put a 6. So then we can just do that on our case. So I've got the furniture equaling 4,800 after V6. So you might just write therefore it's 4,800 after 6 years. Okay, and then D, how long will it take the furniture to be 0? So this is where you can use your solve function and the nth term. So I want the value to be 0. Here's the nth term formula, but I don't know what n is, and that's exactly what I'm trying to find. So I'll just pop solve in here and comma n, and we're going to find out what when does it hit 0. So this one ends up being n equals 10. So you just write therefore after 10 years. Okay, and the last question, do we have another one? E, a photocopier in the office costs 6,000 when you, oh, wait a minute. Okay, look, this is a bit random. A photocopier in the office costs 6,000 when new. Its value depreciates at the flat rate of 17.5%. What is its value after 4 years? So here, we're just trying to do we're using flat rate, and we want to use the nth term formula. So here's where you can just quickly we'll work it out, the nth term formula. So it was 6,000 was VO, and we're going to do the D value, which is 17.5 over 100 times VO. So there's D, I'm marking out D, and then it'll be times N. So let's just tidy that up. So what's 17.5% of 6,000? is 105. So this tidied up will be 1,050. Okay, and they want what's the value after 4 years. So you pretty much want V4. So you go 6,000 minus 1050 times 4. And what do we get? Times 4. So we get 1,800. There you go. So that was the answer to that one. Might just write it out with the money symbol. Okay, so let's have a look at this exam question. So remember I said question 20, so we're a couple into finance, okay? Not too far into it. But it says the graph below shows the value of an asset that depreciates over 5 months. Which of the following depreciation situations does the graph best represent? So if you have a look, if you got to see what's happening with the graph. So see at the start, it drops like one box, and then it drops one box again. Yeah? So when that's actually essentially, that's a straight line. So if it's a straight line there, it is, that would be flat rate, yeah? Flat rate depreciation. Oh gosh, I can't spell. That would be flat rate depreciation. But then what happens, you see, then it drops by 1, 2, 3, 4. But then it also drops by 1, 2, 3, 4. And then it also drops. So this is, it's still flat rate. It's still a straight line. And it's still flat rate. But what happens is this is at a faster rate, isn't it? Yeah? So it's at a faster rate dropping. So therefore the R is a higher percentage. Yeah? Than the blue line. So if you're looking through your answers, it says the flat rate, it represents flat rate depreciation with a decrease in depreciation rate. Did the rate decrease or increase here? Did the R value, it got bigger, didn't it? Yeah, so the R value increased, didn't it? Because if it's going up, but it's dropping by more, it meant the R value got bigger. So this first one doesn't make sense because it said a decrease in depreciation. Did it get quicker? So which one's the best answer there? That second one looks okay. Flat rate depreciation with an increase in depreciation rate. It got steeper, that means it increased, it got quicker. So B will be your answer there. Looking at the other ones, we'll soon learn later that these two, the reducing balance depreciation, that would have been a curved line. So just if you want to put like that on there. And unit costs, it will be a straight line, but it's saying the same as the start bit where it's saying that the rate decreased. It didn't. We definitely increased. Okay, so we just saw in that question before that they talked about unit costs. Now, unit cost is also a linear decay, meaning it reduces by same amount every time. Okay, but except the difference with the unit cost is that the amount is a set cost, and it won't necessarily be a percentage of the original. That's flat rate. What it's going to be is just that it costs. So very common, like things of like this is like, say, the photocopier. Every time the photocopier is used, that its value depreciates it. So they may say 20 cents a copy, or, you know, there wouldn't be that. That 2 cents every time, it's going to depreciate the value of the photocopy machine. Something else is like, say, lawnmowers. Like the value of your lawnmower, if it never got touched, never got used, it will still be very good, yeah? But the more you use it, the thing. So they're going to put a value to every time you use this lawnmower, it will drop in value by this amount. So they're going to tell you that amount. Okay, and then other things are, you might see maybe, I think sometimes the caravans, they say like that, the more you use it, the things. So we'll see it in our examples, but that's what unit cost is. So the difference here, if you look at here, we've got the recurrence relation set up. So this is the recurrence relation. So we can see that. Now, it still has that minus D, but what we're going to do is the D will be what they say is the cost, like the value it decreases when you use it. So they will set that up and tell you. So let's go, but just here on the summary, we can see it's still going to be a straight line. So where it is dropping, this is the cost use drop, okay? Every time it's dropping by that cost use, okay? So let's go have a look at the examples. So a professional gardener purchased a lawnmower for $270. So here I'm going to write VO above it, okay? Now the mower depreciates its value by $3.15 each time it's used. So this each time it's used, hopefully triggers you that that's talking about unit cost, okay? And so therefore they're saying this is the value, so that's going to be my D value here. So they've asked us to set up a recurrence relation, and they're being nice and putting the formula there. If we were in our notes, we go to the one that says unit cost, and here is the recurrence relation. So we would find it and we would be quickly doing it. All right, so let's have a look. We have to write the VO. So it was purchased for $270, and then we're going to write the rule where we just write VN, and then we're going to say minus the cost each time it's used. So it'll devalue $3.50 every time this lawnmower is used, and there's the recurrence relation. Let's do this one. So the value of a lawnmower is modeled by, so here, this is where they're giving you the recurrence relation, and then they might say, they're asking you find, use the value, the formula to find the value after it's been used 3 times. So when they're using the recurrence relation, you'd have to do like I said. So V1, you're going to say is 270 minus $3.50. And equals, so you get, what's that, 266.50. Okay, then you're going to go V2 would be 266.50 minus $3.50, which equals 263. And then you'll say V3 is 263 minus $3.50, which is 259.50. Okay, so what is the value after 3 times? I'm just showing you because that's what the exams will make you set it out like that. So let's just write it out. So you're clear, you get all your points. So how many times can it depreciate before it gets to less than, how many times can it be used before it gets to 250? So with this B, this would be one where you just shove it in your calculator. So we would have 270, then we'd be doing that answer minus $3.50, and we'll just keep smashing it out until we get to 50. Yeah, sorry, 252.5, and then we get 249. So when is it valued less than 250? That's here. So if we count them, so this was 1 use, 2 use, 3 use, 4 use, 5 use, 6 uses. So after 6 uses, okay? Okay, so let's have a look. So obviously we can flick our recurrence relation for unit cost into a nth term one, and here we just got to remember that that D is going to be the cost per use, okay? That's the difference. And here we've got our formula there. So we would write our initial value in and our cost per use there. Okay, so let's have a look, and here's another example. So it says a hairdryer in a salon was purchased for $850. So here's a VO, and the value of the hairdryer depreciates by 25 cents. Now be careful here because they talked about dollars and now it's depreciating in cents. So we need to change that to dollars. So let's change it. I'm going to write that's $0.25, okay? And it's for every hour too. So they're saying the uses on the hour. So let Vn be the value of the hairdryer after n hours. So that's okay. So that matches up. So write down the rule to find the value of the hairdresser after n hours. So let's go. We're finding the nth rule for this unit cost one. So we write Vn equals, we write the VO, so 850 minus, we pop the D value in there, so this is 0.25 and times N. So we've got to be really careful, don't get trapped. A lot of things will decrease by cents because, you know, it doesn't cost that much, it doesn't depreciate that much when you use it. So be careful there. So what is the value of the hairdryer after 50 hours? So that means I'm trying to find V50. So it would be 850 minus 0.25 times 50. A lot of these are common sense. Like you could have worked it out logically. So you don't need to, yeah. So sometimes it's good to think about it like that as well. Okay, so that ends up being $837.50, and then we're up to C. On average, a salon will use a hairdryer for 17 hours a week. How many weeks will it take for the value of the hairdryer to halve? So if we're thinking about it, let's think about this. What is half the hairdryer value? What will that equal? 425? Are you all happy with that? Yeah? So we want to know when that value is that. So I'm going to say when is the value 425? And I'm going to pop in my nth rule formula there. And I'm going to I'll be finding out how many hours this is. So if I do solve, comma n, I'm going to find out how many hours it takes to get to 425. Okay, so I get n to be 1700. So that's 1700 hours. Now it's asking me how many weeks. So if it's 1700 hours, but every week they use it for 17 hours. So if I divide it by the 17 hours, that's going to tell me how many weeks. Yeah, because they said up here they'll use it for 17. So that ends up being, that's pretty easy, isn't it? 100 weeks. Okay, so here's an exam question, and it says, Sienna owns a coffee shop. The coffee machine is purchased for $12,000. So I'd be writing, here's a VO for me, and it's depreciated using the unit cost method. So I've highlighted that, and I know I'm coming to this part on my formula sheet. So I've gone and found it and dropped it on the top. The rate of depreciation is 0.5 cents per coffee made. So that's the D value there. And the recurrence relation models the year to year value. So this is year to year. So what this is, this amount here is, if you did this each year, it's dropping by the 14,400. But it says calculate the number of coffees that are made per year. So we know it costs 0.5. So we're sort of looking at this note, the amount depreciated per period and the number of uses. We want to know what the number of uses is, yeah? So we know it's dropping by 1440, but we know it costs it 0.05 per cost. So then we can do that, and we're going to find out how many times it is used per year, and we get 28,800 now per year. Now have a think about it. It's a coffee shop. That makes sense, doesn't it? That's pretty good value. A coffee shop, a yearly making coffees, that's not unreasonable. So we're happy with that answer. Think about those things with finance because it helps you pick up mistakes. The recurrence ratio above could also represent the value of the coffee machine depreciating at a flat rate, okay? So it could be a flat rate. So what is the flat rate percentage? So remember, they're going to change. They're changing it, and they're saying that the D is still 14,400, but they're saying this is now flat rate. So remember, when we do flat rate, it's the percentage over 100 times VO, okay? So if you know that D is 1440, you don't know what R is, and you know the VO was 12,000, you can pop solve in here, and let's find out what the rate is. Okay, so if we were doing that, the rate would be 12%. So there's that would be the answer, okay? Complete the rule below that gives the value of the coffee machine, MN, in dollars after N cups have been produced. So they just want a cup of coffee. So they want the unit cost nth rule formula. Now they're calling it MN, we often call it VN, so I don't need to write that. We know this would be my VO and this would be my D value. So my VO was 12,000, so I can pop that in. And how much does it depreciate per cup? We're going back to this one, the 0.05, okay? So Sally buys a machine for printing brochures. The machine is purchased for 1,700, so there's VO, and she prints about 25,000 brochures a year. The value of the machine depreciates using unit costs, and the machine reaches us its scrap value at 2,000 after 5 years. Scrap value is a word they use to say what the value of a used machine is, okay? So it just means the current value now or after it's been used. They use the word scrap. Okay, so the rule for the value of the machine after N brochures are printed is, so we need the VN rule. So the VN rule is VO minus N times D. Okay, so we need to first find what, we need a few things. We don't know what the D is. But let's have a look. So it says it was purchased for 17,000. So we could say at V5 is also here. They said after 5 years. So we could say V5 is 2,000. And we know that VO is 1,700. So here's the nth rule. We sort of need to know what it costs per year. So let's have a look. If you think about it, it's how much has it dropped in 5 years? Oh, sorry. It's reduced by what? 15,000? Yeah? So 15,000 over 5 years. So if I'm trying to find out the unit cost, I'm trying to find out the D, which is the unit cost. So what I could do is like per brochure or whatever it is. So I'm going to say it dropped, it's cost, all right, so we're going to use this formula up here. We know it's depreciated by 15,000, and we're going to work out how many uses it used for that 15,000. So they said she makes 25,000 a year, but there was 5 years there. Yeah, so I'm going to do that. So this is going to tell me what it costs per brochure. So if we, okay, so I end up with being that. So then that's like saying 12 cents a brochure. Does that seem pretty fair logic? Yeah, that doesn't sound too bad. So now we know that is, so if we go to write the nth rule using this thing up here, we know it's Vn minus VO. So VO is 17,000. So we could get rid of that one. This one's got an N on it, so I don't like it. So I've got rid of that. And now we go minus, and we just need to put our unit cost in there. And we said it was 12 cents times the number, so it'll be E. Okay, so question 23. Consider the following 4 recurrence relations representing the value of an asset after N years. Okay, so we know they're recurrence relations because it's showing you how to get the next term. Now, how many of these recurrence relations indicate the value of an asset depreciating? So this depreciating means that the value is getting less, yeah? So we've got to look at these scenarios. So if you look at the first one is it depreciating? No. What would this one be an example of? We are adding the same amount. Simple interest, yeah? So this is a growth. We'll write this one's growth. So that's definitely not. What about this second one? Is this one a depreciating one? Yeah, because that minus there is indicating that, yeah? So this one is a decay, okay? Now, what about this next one? If you times something by a number that is less than 1, does it get less? Yeah, it does. So this one is also a decay.
Does it have like a V?
It doesn't matter. We'll learn about these ones. That's a geometric one. Okay, now looking at this last one, it says, all right, so if you look here, this part here is making it grow, yeah? Where this part is making it decay, yeah? So what we need to double check is that the growth, is it more than what it's decaying by, okay? So say for example, let's have a look. If I go, let's look at the first term, and if I do 20,000 and then I times it by 1.125, what do I get? Yeah, so if I do that, I get 22500. So can you see, it actually, this one grew by 2,500, didn't it? But we're taking that away. So what is this one's, what? It's not growing, but then we take it away. So it's not growing or decreasing, is it? It's remaining the same. Yeah. So that one's not a decay one. So how many of these did we end up saying were a decay? Was 2. So there's the answer there. Okay, so this is an exam question. So Samuel owns a printing machine. The printing machine is depreciated in value using the flat rate. So I've highlighted that and I've gone to my flat rate formula in my notes, in my summary sheet. And they've put a recurrence relation here, so that's all good. By what amount in dollars does the value of the machine decrease per year? So they said this formula is for yearly. So how much is it decreasing? You just need to read that recurrence relation. Can you understand what it means? Yeah, good. So we'll write 15,000. That's all we need to write. Showing, so can you see here, this is what I'm talking about when it says showing recursive calculations. That's what we've been doing in all our examples. Determine the machine after 2 years. So you had to show that. So you had to show that V1 equals 120,000 minus 15,000. So it equals 105. Okay, then you had to say V2 equals 105,000 minus the 15,000, which equals 90,000. Okay, so that's what they mean. That's how I said they're going to ask you to step it out, and you're not going to get the mark, and it's only 1 mark, but you need to show, that's how you show recursively, okay? So what is the annual... here, they want the annual flat rate percentage of depreciation. So really, the question here is the R. So what you're going to do is look for something you know that has that R in it. And we know, we've seen that the D formula is the R over 100 times VO. Now I could substitute all that information in. We can see that D is actually 15,000. R is what we want to know. And I know VO was 120,000. Okay, so I can use solve at this point and comma R, and we'll work out what the rate was. Okay, so we got the rate to equal 12.5%. And for a printing machine, that's pretty reasonable, yeah? They do things, they're like, yeah, they drop off quick. Okay, the value of the machine in dollars after n years could also be determined using a rule like this. So this is like the nth term rule, see? Where they're saying pretty much, see how they've got this A here. This A value is like your VO in your nth rule, and your B value there in what they're saying is like your D. So anyway, they're just saying write down a rule. It's like saying write down the nth rule. So we can just write what we normally would do. So we're going to write VN equals, we have to write VO, which is 120,000. And then we have to do, now B, but this is a depreciation, so we're just going to write minus, and our B is 15,000 times N. Okay, so there's that.